Hi, Assalamualaikum. My name is Nur Fatin Ilianis binti Mat Hanifan. My meeting number is 230098. My structure for this project is roof. For material, the material used to build the roof is concrete tiles. Concrete tiles are a type of roofing material made from mold concrete. They are designed to resemble other roofing materials such as slate or clay tiles. Concrete tiles are a popular choice for roofing material because they are durable, low maintenance and fire resistant. Function of roof is protection from the element structure stability, thermal insulation, sound insulation and aesthetic. In this research, a roof structure is located in Kolej Kediaman Luar Kampus UTHM or Kolej Kediaman Perwira di Blok K. It is also located at Jalan Desiswa, Parit Sepadan Laut, X6400, Parit Raja, Johor. Next, this is a free body diagram for roof structure. The structure of this roof is supported by pin and roller. The roof used in concrete tiles to be framed and support. The frame will receive safe weight load and transfer to the support, which is pin support and roller support. This is how to calculate centroid for this roof structure. So, the centroid for x-axis is 4.1 meter and for y-axis is 3.8 meter. Next, this is how to calculate the moment of inertia for this roof structure. So, the moment of inertia for x-axis is 122.04 and for y-axis is 133.42. In conclusion, we explore concrete tiles as a roofing material. Concrete tiles offer durability, low maintenance and fire resistant, making them a popular choice. We also review the key function of roof including weather protection, structure stability, thermal and sound insulation and aesthetic. Importance in civil engineering to understanding roof structure is fundamental in civil engineering for several reasons are safety, energy efficient and aesthetic. Understanding foundation and soil mechanics will be necessary for a more comprehensive analysis. This situation reflects the collaborative nature of civil engineering. When faced with such limitations, civil engineering consult with specialists in other areas or utilize additional data to create a complete picture.
Welcome to my presentation on Checkpoint 2 Bridge. My name is Aisyah Humaira binti Muhammad Alawi and my student ID is DF230139. As you can see from the image on the slide, this is the bridge that I will be discussing today. This bridge is constructed using concrete G20 for both substructure and superstructure, reinforced with 20 mm diameter bars for tensile strength and safety railings for durability. It is vital for community access, particularly for SJKC Chonghua, accommodating both pedestrian and vehicle safely, designed to handle standard vehicle weight. It enhances connectivity and support local activity while enabling quick emergency response, contributing significantly to community safety and efficiency. These bridges are located in front of SJKC's Chonghua, Sri Gading, Johor. They are single-span structure made of reinforced concrete for durability and strength. Each bridge has a span of 10 meters and a deck slab that is 0.5 meter thick. The carriageway is 4 meters wide, designed for one-way traffic and is supported by pin and roller type to reduce stress and allow for thermal expansion. This slide illustrates the free body diagram and the idealized model of the bridge. The idealized model shows a distributed load of 20 km per m over the 10 meter span with support at point A and B. The free body diagram simplifies this to a central load of 200 kN with reaction force at the support. These diagrams are essential for understanding the force and moments on the bridge, ensuring its structure, safety, and integrity. This slide outlines the approximate action and loadings on the bridge. The decking loads transfer to beam and girder, then to supports, with a total load of 20 km per m combining dead and lift loads. The design ensures the bridge handles maximum expected weight for safety and integrity, with the load path illustrated in the previous figure, showing transfer for decking to supports. This slide shows the bridge support reaction. The left pin support resists vertical FAY and horizontal FAX forces, allowing rotation. The right roller support resists vertical forces FBY, allow horizontal movement and rotation. This support ensures the bridge stability and load distribution. This slide illustrates the support reaction for the bridge. Using a free body diagram, the diagram shows a central load of 200 km distributed over a 10 meter span, with reaction force at the support. By applying equilibrium equation, we find that the vertical reaction forces are 100 kN at both support, FAY and FBY. The horizontal reaction, FAX, is 0, indicating no horizontal force. This calculation ensures the bridge stability and load distribution, confirming it can safely support the applied loads. This slide presents the structure analysis of the bridge. Focusing on the centroid of the structure, the diagram shows the bridge dimension and section. We calculate areas and centroid coordinates. The centroid, the point where the structure mass is balanced, is located at 5 m, 0.57 m. This calculation ensures that the bridge is designed for optimal stability and load distribution. This slide demonstrates the structure analysis of the bridge moment of inertia using the parallel axis theorem. The table shows the area, centroid distance, and individual moments of inertia for each section. By summing these values, we calculate the total moment of inertia about the x-axis as 121.72 times 10 power negative 3 cubic meter. This calculation is crucial for understanding how the bridge resists bending and ensures structure stability. This slide shows the calculation of the moment of inertia about the y-axis using the parallel axis theorem. The table breaks down the area, individual moments of inertia, Iy, and distance from the centroid dx for each section. By applying the theorem, we sum this value to get a total moment of inertia of 51.399 cubic meter. This value is crucial for determining the structure resistance to bending. In conclusion, the short-span bridge at SJKC Chongqua is designed for strength and stability, ensuring safety by withstanding both expected and unexpected loads. The bridge materials, size, and strength were meticulously chosen for long-term durability, providing a reliable crossing for the community and ensuring a secure structure for years to come.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Hafiz bin Rez and my number matrix is EF230074. And now I will introduce about our checkpoint 3, which is beam. So the picture show that the site that I used to measure the beams. So next, let's go to the introduction of the structure. About the material, the concrete is a popular material for fixed beams in structures and bridge. Due to the incompressive strength and tensile strength, it's resistant to fire and corrosion, making it ideal for hostile environments, pre-stressed concrete can increase load-bearing capacity. However, its heavier weight affects design and building process. So for the functions, the fixed beams distribute loads effectively due to the resistance at both ends, reducing bending moments and allowing for heavier weights and greater distance. They enhance stability and limiting rotation and lateral movement. So used in bridge, building, and frames. So they have a complex stress distribution and are ideal for construction with moving or oscillating forces. So for the location for these sites is at B303 Block B, Kolej Kedia Mapawira, Jalan Desa Siswa, Parit Sepadan Laut at 0400 Parit Raja, Johor. So next, for this slide, I will show you about the figural idealized model and free body diagram. For idealized model, we can see that the both side of the beam is fit support. So for the free body diagram, we can see that they have the loads which is 180 kN and have the force and moment at both sides which is at point A and point B. For this slide, I will explain about the approximate action and loading for this beam. So, beams in construction are subjected to various loads and forces requiring careful evaluation during the design phase. For the total loading access for the beam is 50 kN per meter, including both deads and live loads. Dead loads or permanent loads are static forces generated by the weight of the building's permanent components. They remain constant through time and must be managed in the design. For the live loads or variable loads are transitory forces that change over the time and include the weight of humans, furniture, equipment, and other temporary objects. They can fluctuate greatly depending on the building function. Alright, this slide will show you about the support reaction calculation for the beam. So as we can see, the center of the load for this beam is 180 kN. By using the equilibrium equation, which is sum of vertical is equal to 0, sum of horizontal force equal to 0, and sum of the moment equal to 0. So for the moment at point A, you can assume that the moment of point A equal to 0, and then we can see the force By we times with 3.6 meter, which is the length, and then minus with the force from the center of the loads, which is 180 kN, times with 1.8 meter. Then we can get the By is equal to 90 kN. So for the vertical forces, which is Fy, we assume that equal to 0, and then Fy equal to Ay plus By minus 180 kN. Then we continue the calculation, and then we get Ay equal to 90 kN. So next, about the horizontal equations, we can assume the Fx equal to 0, and then we can write the Fx equal to Ax minus 2Bx, and then we can get Ax equal to Bx, which is the force at the both sides it says. This slide will show you about the structure analysis for the center of the structure, which is this beam. For this figure, show you the dimension for the beam, and then so for this part, we will find the area of the beam, the x value, the y value, and the ax and ay. Then we can assume that this beam is balanced, which is we get the x is 1.8 meter, and for the y for the centroid is 0.175 meter. So this lab I will explain about the structure analysis for moment of inertia by using the parallel axis method. So first, we need to find the area for this beam, and then we find the Ix value, which is we use the formula BH power of 3 divided by 12, and then we get 0.013. Then for the dy value, we get 0 because of the y value is same with the y value of the centroid, which is 0.175. Then we minus the both y and y of the centroid, and then we get a 0. So for the value for a dy power of 2, we also get a 0 because of the value of the dy. Next, we find the Iy with the formula b power of 3 times h divided by 12, and then we get 1.36. And then for the dx is the same case with the dy, which is the x value and the x value of the centroid is the same. So then for the a dx power of 2, we get a 0 also because the dx value is 0. So the value of moment inertia for Ixx, we get the answer is 0.013 meter power of 4, and for the Iyy, we get 1.36 meter power of 4. So the conclusion for this part, which is beams, is we can assume that crucial for enduring large load and providing increased stability. Ensure with solid supports, they reduce deflection, ensuring structural integrity and safety. Reinforced concrete blends concrete's compressive strength with steel tensile strength, making it resilient to various stress. Next, complex stress distribution requires careful design for enduring induced moments and shear force. Then we can learn that the ideal for high-rise buildings, bridge and industrial structures due to their low movement and high load-bearing capacity. Next, we can know that this is ideal for the hostile environments due to resistance to fire and corrosion. And lastly, for the conclusion is we can improve building stability and lifespan, meeting safety standards and performance requirements.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zahgimi Berazi. My metric number is DF230040, and this is my structure, column and beam. So we will find out the support reaction, centroid, and the moment of inertia of this structure. First, the introduction of the structure. For the material, the column and beam structure usually made of reinforced concrete. Reinforced concrete is popular because it is strong under compression, durable, and can be shaped to meet various design needs. Steel reinforced bar or rebar are added to provide tensile strength. This combination allows the structure to handle both compressive and tensile loads. For the function, this structure in a building supports and transfer load from the floor, roof, and other structural elements to the foundation, with beam distributing horizontal load to columns and columns transferring these loads vertically to ensure the building's stability and integrity against various forces. These structures are located in B6 block of main campus of University Tun Hussein On Malaysia. Next, for the free body diagram part, the diagram shows the center load of 46 kN distributed over 4.6 meter span beam. The horizontal support relation Fax is equal to 0, show that no horizontal forces acting on the structure. By applying equilibrium equation, we will find the vertical forces are 23 kN at Fay and Fby. Next, we move to the structure analysis part, which is we find centroid. The diagram shows the beam and column, section and dimension. Using the calculation, we can find the centroid of each section and the centroid where the structure is balanced, which is at 5 meter at X and Y at 0.7 meter. To find the moment of inertia using parallel axis theorem, we have to sum up the values that we have calculated, and after summing the values, we can identify the total moment of inertia. For the x-axis, it is 178.63 meters squared. Next, we have to find the total moment of inertia at y-axis. Same with x-axis, we have to sum up the values that we have calculated, and we get 76.2 meters squared. For the conclusion, beams and columns are essential for maintaining building stability, with beam distributing horizontal loads and columns handling vertical compressive forces, ensuring effective wave management and structural integrity. Besides calculation of support reactions, centroids and moment of inertia are crucial for designing strong and stable structures, guiding material selection and construction method. Together, these elements and calculation ensure building can withstand various forces and remain safe and durable.
Now, you arrive at checkpoint 5, and it is about a structure called stairs. Alright, hello, my name is Muhammad Yashar Maliki. Now I wanna present on my part. Now, the location of the stair that I have observed is located in Block B301, Block B, College Kediaman, Perwira, at Baik Raja. Okay, the material that stairs use is overall is concrete, and it is a widely used material due to the strength, durability and versatility. Now the functions of each component of the stairs, which is, can say, the beams can distribute the loads from the stairs to the column and other supporting structure. They help spread the weight evenly, preventing excessive stress on any single point, any single joint in every structure of the stairs. Alright, now so this is my free body diagram, which is, as you can see, there is a tree reaction, which is from the A and B, and also there is a loop, whereas there is, which is 3 kilonewton. Okay, now the approximate actions loading that happen on the stairs, which is in stairs construction, beams and column are critical for ensuring structural integrity and load distribution. The primary loads to consider are dead loads, which include the weight of the stairs and structural elements, and light load, which account for the weight of people and movable objects. For instance, concrete tracks and risers contribute significantly to the dead load, calculated based on their volume and the density of the concrete. Live loads specified by building codes are typically around 4.8 kN per meter cube. These loads are transferred from the tracks and risers to the stringers, which then convey the loads to the beams and columns. Now for the support reaction, as you can see, I calculate the Fy, Fx and a momentum, which result is the Fx is 3 kilonewton, and momentum is calculated by calculating the force and distance, which is 3 kilonewton times by 1.25 meter, and equal is 3.75 kilonewton meter. Alright, now for this part, we need to analyze the structure. Okay, the first step we need to do is we have to calculate the centroid of the structure, which is already separated in 3 parts, which is A, B and C. And then we have to calculate the area of each structure, and then calculate the point, and then times the both of it, which is areas and the coordinate of each the structure. And as a result, we have to total the AX, AY and the area, and then we have to calculate the X, which is the formula is AX over the area, which is we can get from the A is 1.8, and then from the Y we get 2.1. Okay, after that the next step, which is we need to calculate the moment of the inertia, is still the same. You have to calculate the area and then calculate the Ix, which is you can use the formula of y times by h power of 3 minus over 12, and I get the 1.8, 0.7 and 1.8, and then calculate the dy, and after that we have to times area with the dy. After that we have to do the addition of each object. So I get 5.4 meter power of 4 after the calculations, and then the same thing goes for the y-axis, where the difference is we have to calculate the IY and the DX. After that, times with area we get the ADX, and then add this to do the addition with 3 of the result, so we get a 8.6 meter power of 4. Okay, now last but not least, for summary, fixed supports play a vital role in ensuring the safety and performance for structural systems. Their ability to provide comprehensive restraint and support is balanced by the need for precise construction and sophisticated analysis techniques. By understanding and effectively utilizing fixed support, engineers can design robust and reliable structures capable of withstanding a wide range of environmental and operational stresses. Thank you.